So, like I was telling you, number one, I intended you to use your special right triangles, but really, you can use trig, and I'll show you both ways. Okay, so for number one, you were asked to, there we go. You were asked to find the missing sides and leave your answers in simplest radical form. Awesome. It's going to be one of those days, I guess. Alright. Hopefully it's working. Yes. Okay, perfect. Alright, so you were asked to find the missing sides, okay? So you need to ask yourself if you're using your special right triangles. So first of all, this is a 30, 60, 90, and this 6, is it a leg or a hypotenuse? It's a leg, okay? So for a 30, 60, 90 triangle, your legs are either s or s squared of 3, okay? Which angle is 6 across from? 60. So what does that mean that leg is? S squared of 3. Good. Okay, so that means y is going to be s, and what's my hypotenuse for 30, 60, 90? 2s. Good. Okay, so, but in order to figure out what 2s is, I need s. Okay, one thing that happened on the quiz was, like, for example, I can't draw it out because not everyone's taking the quiz, but you were given the hypotenuse for the 45, 45, 90, and it didn't have the square root of 2 with it, and then a lot of you just said, oh, well, the legs are going to be the exact same thing. No, you actually have to go figure out what s is, okay? So, remember, we set it up like an equation. 6 is s times the square root of 3. How do I get s by itself? Divide by the square root of 3. Alright, and you're going to need your calculator for that. 6 divided by the square root of 3 is 2 square root of 3. So s is 2 square root of 3. That's this. That's the answer for this. Okay? And then from there you need 2s. So take s, which is 2 square root of 3, and multiply it by 2, and it should be 4 square root of 3. Hopefully. Okay. Alright, and then if you want to do it the trig way, which we didn't talk about yesterday, but talk about it now. I know, as long as you know an angle on one of the sides, you can do trig. Okay? So, say I want to do trig, let's say I want to figure out y first. Okay? How does 60, or how does 6 relate to 60? Is it opposite, adjacent, or hypotenuse? Opposite. And how does y relate to 60? Adjacent. OA, which one do I use? Tangent, okay? So tangent of 60 over 1 is 6 over y. And when you solve that, y times the tangent of 60 equals 6. Divide both sides by tangent of 60. You'll get a decimal, but remember, if you hit those arrows right above enter, it should, I think, hopefully. We'll see what happens. Tangent of 60. Yeah, so mine already gave it to me as 2 square root of 3. Okay? So you get the same answer regardless. Personally, I think trig's a little easier. Okay? Up to you, though. I still think it would be a good idea, though, to know your sides and your hypotenuse for your special right triangle. That way you can confirm that you're correct with trig. Okay? So either way you do it, you should get 2 square root of 3 for s and 4 square root of 3 for y. Okay? Alright, and then for number 2, you need to find the missing side, round to the nearest tenth. Okay, so for here, you got to use trig. Okay? So, we need to ask ourselves, how do each of these pieces relate to this 15 degrees? Okay? SOHCAHTOA. Don't forget about that. SOHCAHTOA. Alright, so how does 14 relate to 15 degrees? Opposite. So that throws out which one immediately? Cosine. Cosine's gone. And then this x, it's adjacent, but you have to ask yourself, is it a hypotenuse? Yes. So O over H, which one is that? Sine. Good. So sine of my angle over 1 equals opposite, which is 14, over my hypotenuse, x. Alright, from here, cross multiply, just like we talked about yesterday. So x times the sine of 15 equals 14. And then lastly, how do I get x by itself? Divide. So divide both sides by sine of 15. And when you do that, 14 divided by sine of 15. Okay, mine gave it to me in radical form, but if you hit the arrows right above enter, it should change it. Said round to the nearest tenth, so x is approximately what? 54.1, very good. 54.1, yeah, Kaylee. Fine, okay. So I have the 14th opposite, and then the x, it's adjacent, but it's across from the right angle. So it's got to be a hypotenuse. Okay, remember that adjacent, I don't think I emphasized this enough yesterday in here at least. Adjacent can only be for a leg. Okay, a hypotenuse is a hypotenuse. Okay, so if it's adjacent next to the angle, you need to make sure it's not a hypotenuse. Okay, if x were over here, then that would be adjacent because it's not a hypotenuse. Okay, your hypotenuse is your hypotenuse. The only things that can be opposite and adjacent are your legs. Okay, so don't forget about what a hypotenuse is. Okay. Alright, a little lengthier bell ringer, but just wanted to address some things since we didn't have one yesterday. Are there any questions? Alright, you may put that away and take out today's text. If you don't have a calculator of some sort, go ahead and take this time to grab one. Okay, you can do trig on your phone. I'll remind me at the end of the class. I'll show you how to do that. Okay, you can do trig on your phone, but it's the special right triangles that you need one of these for. Okay, but if you're working at home tonight, there shouldn't be an excuse or whatever saying, "Oh, I didn't have a calculator," because you can do trig on your phone. Okay. All right, so we are actually skipping 4.5. We're going to come back to it. The reason for that, I'll just go ahead and address it. I have to attend a training tomorrow during first and second block, so I'll be on campus, I just won't be in here. And this lesson, to me, is way more challenging, quote-unquote challenging, way more challenging than 4.5. But the problem with 4.5 is I really need to be in front of you to make sure you're typing it in the calculator correctly, because it's all calculator. Kind of like yesterday, a lot of calculator. So I wanted to go ahead and get this lesson out of the way, because it's more challenging than 4.5. And I wanted to wait on 4.5 because I wanted to be in front of you with your calculator. Okay? So what you're going to do tomorrow, at the end of class, I'm going to hand you your review. Go ahead and hand it to you early. And I'll tell you what problems I want you to work on in class tomorrow. Okay? So that means your test is for sure the 16th. Okay? End of quarter is the 17th. So if you're missing a test, it needs to be done by then. Any makeup work needs to be done by end of class. Okay? Your bonus project, due the 15th. If you decide you want one, let me know. Okay, that's due the 15th at the beginning of class. The 16th is your test. 17th end of the quarter. Okay, so long story short, that's why we skipped 4.5. We're going to do 4.5 on Friday. Okay. Any questions about? So you'll report here tomorrow. Miss Floor, she's one of the teachers on Affordable. She'll be over here, and I'll be on campus. I just won't be in here. Okay, so if you have questions or anything, you can message me. I'll do the best I can to answer. Okay. Sounds good. And I trust that y'all will behave. Just don't abuse it. Don't go sniffing, whatever, because you do have stuff you need to accomplish. Okay. All right. Now let's talk about today's lesson. Okay, so today's lesson is 4.6. called angles of elevation and depression. Okay, it's not mental health depression. Okay, that's just what it's called. Okay, so angles of elevation and depression, and essentially, not to scare you, but today is a word problems. Okay, but the biggest part about it is if you can draw a picture, then it's just true. So you just have to use the word problem to draw the picture. Okay, promise it's not as bad as it seems. I know we get freaked out by word problems. Same thing with fractions. We freak out. Okay, just breathe. Take a second, read the statement step by step and draw as you go, okay? Because you got to be able to draw a picture of this, okay? But first, let's talk about what angles of elevation and depression are, okay? So an angle of elevation is formed by a horizontal line and a line of sight above. So if I'm standing and I'm looking up at this light, this angle right here from my nose to up here is my angle of elevation, because I'm looking up. Okay? Your angle of depression is formed by a horizontal line and a line of sight below. So if I'm standing right here and I'm looking down at the ground, this angle right here is the angle of depression. Okay, so the angle of elevation is above your line of sight. The angle of depression is below your line of sight. Okay. All right. Let's see if we remember this. Okay. Thinking back a little bit. Say I have two parallel lines, and this is a transversal. Okay. So thinking back a little bit. All right. So these are my angles. That's my angle of depression. That's my angle of elevation. What types of angles are those? What's the name? Alternate interior. Very good. What do we know about alternate interior angles? Are they congruent or supplementary? Congruent. Okay, so those angles right here are alternate interior, which means they're congruent. Okay? So what I'm saying is say you have an angle of depression, but you know the height of this balloon, for example. See how this angle is outside the triangle? Your angle of depression? You can redraw it down here because of alternate interior. Okay? I promise that'll make a little more sense once we do an example. But your angles are always going to be right there or right there. No questions asked. Okay? And if your angle ends up outside the triangle, you can move it to be there because of alternate interior. Okay? Alright. Let's just practice identifying angles of elevation and depression first. Figuring out, is it an angle of elevation or an angle of depression? Okay? So, first I'm asked about angle 3. Okay? So remember, with angles of elevation, the angle is formed above the line of sight. Okay, so that dotted line is your line of sight. Okay? And then angles of depression, the angle is formed below the line of sight. Okay? So what does that make angle 3? An angle of elevation or depression? Depression, good. Okay? This is my line of sight. The angle right here is below the line of sight. So because it's below the line of sight, that's depression. So what does that make angle 4 then? Elevation. Okay, that's above the line of sight. Okay, so angle 4 is elevation. Just think about it. Elevation usually means you're increasing in height, right? So think about it that way. If you're looking up, it's an angle of elevation. If you're looking down, it's an angle of depression. Okay? Alright, let's do some additional practice. Okay? So for number 1, so once again, my dotted lines are my line of sight. Okay? So angle 1, I'm at the tower, and this is my line of sight. So this angle is above the line of sight, right? Does that make it an angle of elevation or depression? Elevation, because it's above the line of sight. The dotted line is my line of sight. Okay? So I'll write from lighthouse, if that helps. I know the picture's a little hard to tell. So number 1 is from the lighthouse. Okay? Number 2 is if you're the bird. Okay? So the bird's line of sight. Okay, so the bird, this is its line of sight, the angle's right here. So is that an angle of elevation or depression? Depression, good. Because the bird is looking down. Alright, number 3 is also from the lighthouse. And I'll just go ahead and say 4 is from the boat. Okay, so number 3, I'm from the lighthouse. This is my line of sight. The angle is below. So is that depression or elevation? Depression, good. And then number 4, I'm on the boat. This dotted line's my line of sight. The angle's above. So what does that make it? Elevation, good. Good, good. All good with being able to just identify angles of elevation, depression? Your angle of elevation above the line of sight, angle of depression below the line of sight, okay? Alright, we're going to skip this first problem because it addresses 4.5, and clearly we haven't talked about 4.5, so we will come back to it. I don't want to address it until we talk about it. Alright, so let's go to number 2. Alright, so these first 2 pictures are drawn for you, okay? So, you're asked, when the angle of elevation to the sun is 52 degrees, so that means I'm looking up. Okay? So for example, this is my line of sight. I'm looking up. So that angle is going to go right here. Okay? When the angle of elevation to the sun is 52 degrees, a tree casts a shadow that is 9 meters long. Okay? Think about a shadow. When you're walking outside, the shadow's in front of you, right? That's the horizontal. Okay? So just use a little common sense. Okay? The shadow is horizontally in front of you. Okay? It's not up and down. Okay? You're asked for the height of the tree. So that means you need the vertical, right? You want to know how tall the tree is. Okay? So that's what you would do in your picture. Take it step by step. It's an angle of elevation. I'm looking up. A shadow is horizontal. So I know that length. I want to know how tall the tree is. That's a vertical. The tree's not leaning. It's not a hypotenuse. Okay, so just use a little common sense when you're doing this. Okay? I need the height of the tree, and I need to round to the nearest tenth of a meter. Okay, so now I need to figure out sine, cosine, or tangent. Alright? So, remember, you're relating everything back to the 52 degrees. Okay? So, 9 meters, that's horizontal. Is it opposite, adjacent, or hypotenuse? Adjacent, good. Next 2. Okay? What does that eliminate immediately? Sine. Sine has nothing to do with adjacent. Eliminate it. Okay? That X, the height of the tree. Opposite or a hypotenuse? Opposite. Which trig ratio am I using? Tangent, very good. Alright, so tangent of my angle, you always set it up like that. Whatever the trig ratio is, followed by your angle. So tangent of my angle, which is 52 degrees, I'm just going to go ahead and put it over 1, equals opposite, which is x, over adjacent is 9. So remember that tangent is opposite over adjacent. From here, plug it into your calculator. So we need to cross multiply. X times 1 is x. 9 times tangent of 52, that's what I need to figure out. And I want your answer to the nearest tenth of a meter. So that is 1 decimal place. So x is approximately what? 11.5 meters. Thank you, Lexi. Meters. You're given a unit. You need to put the unit. Okay? If you're not given a unit, don't worry about it. 11.5 meters. Good. Right? Like I emphasize almost every day, I know I sound like a broken record, but word problems I understand are overwhelming and they can get confusing. So if you're not sure how I'm drawing a picture, you're not sure where I place something in a certain place, ask. Okay? Alright. Number 3. A person snorkeling sees a turtle on the ocean floor at an angle of depression of 38. So think about it. The person snorkeling's up here, they're looking down at the ocean floor, so that's an angle of depression. Okay? She is 14 feet above the ocean floor, so that's how high up she is from the ground. So that's a vertical. How far from the turtle is she? Okay? That's not going to be this distance, because if it were this distance, she would be down here. Okay? Does that make sense? Why it's the hypotenuse and not here? Maybe? I remember last semester students having trouble with that. It's not the horizontal because she's not down on the same level. Okay? It's the hypotenuse. Okay? So notice that the angle is not inside the triangle. Okay, so that's what I was meaning earlier. So you can do one of two things. These are alternate interior, so you can move the angle to be right here. Or you can just straight a dotted line. That's her line of sight. She's still 14 feet from the turtle, or 14 feet above the ground, right? So either way you do it, whether you want to draw a dotted line and create this triangle, or just move the angle right here since they're alternate interior, it works. Okay? That's the hardest part to me about angles of depression. Okay? So either one works. Draw a dotted line, this is 14 feet. Or you can say that angle's 38 degrees because it's alternate interior. Okay? Alright, from here, now we can work as normal. Figure out which trig ratio. SOHCAHTOA. Alright? So I know I have a hypotenuse. So which one gets eliminated immediately? Tangent. Tangent's gone immediately. That one doesn't deal with the hypotenuse. Okay. 14. So relate it back to the 38 degrees. Is it opposite or adjacent? Opposite. Okay? Depends on which triangle you look at. Okay? If you're looking at this triangle right here, you got to look at the 14 over here. If you're looking at this triangle, you got to look at the 14 over here. Okay? So regardless, it's opposite from 38. So opposite over hypotenuse, which one am I using? Sine. Good. Sine. Okay, so sine of 38 over 1 equals, let's see, 14 over x. Alright, I want you to go find x, round to the nearest foot. Okay, so that means I want a whole number. The nearest foot. When you cross multiply, you're going to have to divide by sine of 38. And x to the nearest foot is what? 23 feet. Good. 23 feet. Don't forget about your units. Okay? All good? Alright, now flip to the back. Now we gotta come up with a picture ourselves. Okay? Alright. So, take it piece by piece. Okay? Piece by piece. Alright. One thing I want you to change real quick, I forgot to change it. The angle of depression is 47 degrees, not 20. So change that on your paper. The angle of depression is 47 degrees, not 20. I apologize. It's a typo on my end. Alright. Sarah is watching a parade from a 20-foot balcony. Okay? Here's Sarah. Alright? She's on a 20-foot balcony. That's a vertical, right? How tall is the balcony? 20 feet. Okay? The angle of depression, so let me think. That would be here. Yes. Okay, so here's the right triangle. The angle of depression is here. So that is 47 degrees. Remember, it's below the line of sight. Okay, so initially it may not fit into your triangle, but remember we can fit it in. Okay? What is the distance between Sarah and the parade? So think about that. Is that going to be this other leg of the hypotenuse? The parade's down here. That's your parade. So I want, how far away is Sarah from the parade? So is that going to be the horizontal leg or the hypotenuse? What do we think? Okay, is Sarah on ground level with them? No. Okay, so think about that last problem we just did with the turtle. The snorkeler was above the turtle, right? And I wanted to know how far away she was from the turtle. Which did I use? Hypotenuse. Okay, so you can't use the ground unless she's on ground level with them. Okay, because that ground level distance is going to be more than, like, if I was, for some reason, standing on this. I don't know why I would be. But if I was standing on this, my distance from me to Lexi would be more than this. Okay, so what would it be? Hypotenuse. Okay, it would only be ground level unless she was on ground level with the parade, but she's not. Okay, does that make a little more sense? It can't be the horizontal leg unless she's on ground level with the parade, but she's not. She's above the parade. Okay. Like I said before, you can do one of two things. That's where your angle is going to go if you decide to move your angle. It's alternate interior. Or I can say that this is 20. Either or. Whatever's your preference. Are there any questions about the picture? Okay, because once you do the picture, you can do the math. But that picture's got to be right. So that's the biggest thing with this lesson. Can you draw the picture? All right. How does 20 relate to 47? Opposite, good. So that throws out the cosine. And then I have a hypotenuse, so which trig ratio am I using? Sine, good. Okay, this is really just like the last problem. Just needed to draw a picture for it. Okay. So sine of my angle over 1 equals opposite over hypotenuse. Okay. You go ahead and find x. It doesn't say, so round to the nearest tenth of a foot. One doesn't, like round to the nearest tenth. And don't forget about your units. What is x approximately? was 3. One decimal place. So 27.3 feet. Perfect. Alright, one thing I want to mention real quick, because I just realized I haven't. So, we haven't talked about pi yet, but anyone know what pi is? Like the number? 3.14, okay? Well, Monday, if you look at the date, will be 314, okay? I have a fun activity that we're going to do on Monday. It doesn't relate to pi, unfortunately, but it does relate to trig. So, if you would like to bring circular food, whether it's cookies, Oreos, whatever, I will give you that option. Okay? Okay? So we'll have a fun activity to do. It doesn't relate to pie, unfortunately. It relates to trig. But if you would like to bring a circular food on Monday, you're welcome to. Okay? So, up to you. But remember that you're providing for the class. Okay? So if you bring Oreos, bring enough Oreos for the class. And there's 27 of you. Okay, so attack of 30. Whatever. Okay. So, just wanted to put that out there. Don't feel pressured to, but if you would like to, that option is available. Okay. Alright. Let's keep moving. 3 more problems. Alright. An electrician leans an extension ladder against the outside wall of a house so it reaches an electric box 28 feet up. Okay? First things first, you're going to have a right triangle. Draw it. It's going to be a right triangle. Okay? Whether you draw it this way or this way, I don't care. Just draw a right triangle, because you're going to have it. Okay? So let's reread that first statement again. An electrician leans an extension ladder, blah, 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 so that it reaches an electric box 28 feet up. Okay, so if I label these sides 1, 2, 3, where is that? Don't write that down. Okay. Where is the 28 feet going? 1. You see that? The electric box is 28 feet up. There's the box. Okay? So 1 is 28 feet. That's what I'm meaning by take this piece by piece, okay? Because if you try to read all this at once, you may get a little overwhelmed. So take it step by step, sentence by sentence. So we've addressed that. Okay? So we know since we're going up, that it's got to be an angle of elevation. Okay? The ladder makes an angle of 60 degrees with the ground. So if I label these angles X and Y, where's the 60 go? There's the angle of elevation. Y. Okay, I'm looking up. Okay, so the 60 is going to be at Y. Because I'm looking up. Okay, if I was looking down, let me also. When I had an angle of depression, so say my angle was right here. It still ended up here, right? Okay, so your angle is never going to be here. Okay, it is always going to be here. Just depending on how you draw the picture. Okay? Yeah, Milo.
So you said the box is
No. We're down here. The box is up.
Oh.
Yeah, the box is up here. We're looking up at the box. So think about it. You're climbing the ladder to go up to the box. So that's an angle of elevation. You're going up. Okay? I don't think that actually. Okay, anyway. Find the length of the ladder. So what is that going to be, 2 or 3? Where's the ladder? Is the ladder leaning against the wall or is it on the ground? Leaning against the wall, okay? This is the wall. Okay? The box is 28 feet above the wall. Okay? So say it again, 2 or 3, where's the ladder going to be? 3. The ladder's 3. Okay, the ladder's not on the ground. Okay, that's what I'm meaning, take it piece by piece. Alright. So the total. Alright, how does 28 relate to 60? Opposite. The cosine's gone. And that x, is it adjacent or hypotenuse? Hypotenuse, so which one am I using? Sine. Okay, you're probably seeing a trend that sine and tangent get used a lot. Okay, so just keep that in mind. Sine gets used a ton, and tangent gets used quite a bit too. It's cosine doesn't happen too often. But these, yeah.
Okay, so when you say the opposite, like, what do you mean?
It's not next to it. So these are next to it. So 60 is across. Or, I'm sorry, 28 is across from. And opposite is the only one that's not next to the angle. Okay, so you go ahead and set it up, and you solve it. Set up your equation, you solve it to find x. I want it at the nearest hundredth of a foot, so 2 decimal places. Go ahead and compare your answers if you haven't already, while I'm solving it. What is x approximately? 33 or 34? 33. 32.33. What was the number that came after the 3? 1. Okay, so that number would change to a 4 if this number right here is 5 or higher. Okay, if it's not 5 or if it's less than 5, it stays. So if it were 0.335, then it would be 0.34. Okay. Okay. Are there any questions about the picture? Yes. No? Any questions about the picture? Yeah, that's the hardest part about this is getting that dang picture right. Okay? Take it step by step, sentence by sentence. Okay? Yeah, 10.
What is it? I think it's calculated and then 53 times 9 and then give me 11.5. So you have to do like 9 times 10.
Okay, you can do tangent of 52 times 9, but that 9 can't be inside the parentheses of the 52. Because then you're saying tangent of whatever 52 times 9 is. So that would be tangent of 468. Yeah, so if you do tangent of 52 times 9, you have to say tangent of 52, close the parentheses, then multiply by 9. That's a good question. Good question. All right, 2 more problems. All right, draw a right triangle. Okay, first step, draw a right triangle. All right, Hannah leans a 16-foot ladder against a wall. Stop there. 1, 2, or 3? 3. Very good. 3. Okay, the ladder is leaning against the wall. So that is your hypotenuse. Very good. That's 16. Whoops. Questions about that? Because it's leaning against the wall. This is your wall right here. This is my ladder. So it's leaning against the wall. So that's the hypotenuse. Okay, if you need to draw that a little more elaborately, like draw a ladder, draw a person, do it. Whatever works for you. As long as I can see the right triangle. Okay? It forms an angle of 61 degrees with the ground. Your angle is always right here. Okay, does it say anything about anyone looking down? No, so you don't have to draw this angle of depression stuff. Okay? Alright. What is the horizontal distance between the base of the ladder and the wall? 1 or 2? 2. Okay? Horizontal distance, that should give it away immediately. Horizontal, that's 2. Left and right. Okay? It's asking the distance between the base of the wall and the base of the ladder. So the bottom of the ladder is here, the bottom of the wall is here, that's 2. So that is your X. Keep doing it. Yes. The angle always goes right there. It's an angle to elevation because I'm climbing up the ladder.
And this is always
Pretty much. Yep. Because even if it were an angle of depression, so if it was an angle of depression, the angle's right here, but like we talked about, alternate interior, the angle will move right there. So it's always going to be right there. Alright. Which trig ratio am I using? Cosine. Okay, so this one is, I wanted to throw in at least one cosine to also prove to myself that cosine does get used. Okay, so cosine. Good. Okay. 61 is adjacent, or I'm sorry, x is adjacent to 61, and then 16 is a hypotenuse. So that's co and your SOHCAHTOA. Alright, so cosine of my angle over 1 equals adjacent, which is x, over my hypotenuse 16. You're asked to round to the nearest tenth of a foot, so 1 decimal place. Alright, x is approximately what is x? Say it there. Good, 7.8 feet. Did we not get that? Or just critically good? Okay, y'all gotta talk to me, okay? If there's something you're not understanding, something's not clicking, you gotta talk to me, okay? Otherwise, I have no idea. Yes.
so. What do you do?
16 times the cosine of 61 is what I put in my calculator. Because when I do the cross multiplication, I have 1 times x, so x is already by itself. So I just need to say this times this. So just 16 times the cosine of 61. And that gets you your 7.8.
What do you do?
Which rounds to 7.8. Yep, that rounds to 7.8. All good? Alright, let's do this last problem. Okay, this last problem, I'm not going to give you anything like this on your test unless it's like a bonus, because this problem is, in my opinion, pretty complicated. But it does show up on your Delta map, so I wanted to at least do it, that way in case it shows up on your Delta map, you've at least seen it. Because last semester I had no idea it was on there, and then lots of my students got it, and I haven't gone over it at all. Alright. Alejandro is flying a kite, holding his hands at a distance of 3.5 feet above the ground and letting all the kite string play out. We're going to skip that for now. Okay, we'll see why in just a second. We're going to come back to that. Draw your right triangle. Whatever way you want to draw it, I don't care. Alright. He measures the angle of elevation from his hand to be 23 degrees. Where's that going, X or Y?
Y.
Y. It's always Y. Okay. 23 degrees. If the string, so this is Alejandro. Okay, sometimes it helps me to actually draw that. Okay, that's Alejandro. If the string from the kite, so kite's up here, obviously above the ground. If it was at the ground, that would be a really poor kite. If the string from the kite to his hand is 125 feet long, stop there. 1, 2, or 3. If the string from the kite to his hand, 3, good. So that's 3. So that's 125. How many feet is the kite above the ground? 1 or 2? 1. That's your vertical distance. Okay. So that is your X. Alright, let's figure out this height first, and then we're going to come back to that 3.5 distance. Come back and forth. Okay. Sine, cosine, or tangent? Sine. Good. I have opposite, and I have a hypotenuse. So that is sine. Okay. If you still need to write out, the whole SOHCAHTOA business and cross it out, that's fine. But my hope is that eventually you can just look at the picture and know, hey, that's sine. Hey, that's tangent. Okay. Alright, so sine of 23 over 1 equals opposite over hypotenuse. Alright, so when I cross multiply, I get 125 times the sine of 23 equals X. What do you get? 48, round to 2 decimal places, I'm sorry. 48.84, okay? That's not my answer, and I'm about to tell you why. It's because of that 3.5 we talked about, or we skipped, okay? Alejandro, so let me read that again. Alejandro is flying a kite, holding his hands at a distance of 3.5 feet above the ground. So his hand is 3.5 feet above the ground. Okay, so that's 3.5. Because this is the ground. Okay, that's the ground. Okay, the question asks me, how high is the kite off the ground? So what do I need to do with that 3.5? Subtract or add? You would add. Okay, because this is 48, but then I need this too to figure out how high it is above the entire ground. Okay? So, remember, don't round until the very end. So take your answer, 48.841, blah, blah, blah. Take that entire thing and add 3.5 to it, and then round to 2 decimal places. So the kite is how many feet above the ground? 0.23. 34 feet, good. 52.34 feet above the ground. So if you neglected that 3.5 and type in 48.84, it's going to mark it wrong. Okay? Like I said, I won't give you anything like this on your test unless it's like a bonus. So hint, hint, maybe. I don't know. I haven't decided. But add the 3.5 to it at the end. Probably yes.
Okay, so how do you know who's supposed to like divide or multiply?
It all depends on this cross multiplication. Okay? So if I had 125 over x, I would have x times sine of 23. I need to get x alone. But when x is in the numerator, x is already by itself, so all I need to do is multiply. Okay?
But how would you know who?
It depends on your ratio. So this was my opposite over hypotenuse. So x is opposite, that goes in the numerator. If x was my hypotenuse, then x would go in the denominator. Because remember, sine is opposite over hypotenuse. So opposite is x. That's what I'm missing. That goes in the numerator.
Okay.
Don't try and find a trend. Okay, don't. I was having issues with that in my other classes yesterday. Don't try and find a trend. Just set it up, solve it like normal. Okay. All right. Your homework on Delta Math is 5 problems. Okay, 5 problems. You need scratch. Okay, because obviously you got to be able to draw a picture. Okay, if you're struggling with it, ask questions, and then I know we didn't really get time to do yesterday's homework, so you have that to do as well. Okay. Let me go ahead and hand you your review. And before you put it away and start your homework, let me tell you what problems I want you to do during class tomorrow. Okay? Alright, don't lose this, please. I'm letting you work ahead. So maybe on review day, if you're done with your review, we can do something a little more fun. Alright, so this is what you're working on during class tomorrow. Like I said, I'll be at a training. I'll be on campus, just won't be in here. So this is what I want you working on during class tomorrow. Hopefully we'll be able to do it. We'll see. Alright, so for tomorrow, so tomorrow, problems 1 through 14. So that's Pythagorean theorem, triangle inequality theorem, and then 21 through 30. So that is what we did yesterday. If you want to try and tackle, there's 2 problems on the very last page on the back of the word problems. If you want to try and tackle those, you can. Work with others. I don't care. You'll have a calculator since you'll be in here. So use your resources. I'll be on campus, just not in here. So if you have questions, you can message me. But this is what I want you to have done. Problems 1 through 14 and 21 through 30 by the end of class tomorrow. Okay, you're not going to split it anywhere. And then if you finish before then, you can continue working on your homework. Okay? Or your bonus project. Okay? So are there any questions about what you're doing now and what you're doing tomorrow? All right. That Haley. For which homework? If you did all of it, don't worry about it. As long as you have something, I'll take it, okay?